Today we're going to work on worksheet 4B. And the first question here is saying that we have this circuit over here to the right, and that's the voltage through the capacitor, and it lags the voltage across the resistor. So this is the resistor, this is the capacitor. They're telling us what the voltage is, and they've actually given us a picture. Our voltage is going straight across. Our capacitance is going down because it's lagging at a negative 90 degrees. So this is 90 degrees here, but it's going negative. And it wants us to find the total voltage. I could make it very complicated, but I don't see the point, because we can say here VR, since it's going in the positive X direction, 10 volts, it's just 10 I. And VC is just going negative because it's going down 20, but we're saying in the J direction. Here I have VR and VC, so vector V. So vector V is just going to equal 10I minus 20J. They're not actually asking you for the magnitude of the voltage. If they ask you for the magnitude of the voltage, I think we should do it. We can just say that the magnitude of the voltage in vector V is equal to, well, if you notice, it's just the Pythagorean theorem. So we can say that it's equal to the square root of 10 squared plus 20 squared, which is equal to the square root of 100 plus 400, which is 500. So this is equal to 10 times the square root of 5 volts. So this would be the magnitude. That's not what they're asking for, but in case you were wondering, that's that. But if I just told the magnitude, if someone asked me about the voltage and I just gave them an answer in the magnitude of the voltage, we wouldn't know how they're related. Vectors actually always have to have magnitude and direction. This tells me the direction. This tells me the magnitude. I also can find the magnitude just from the vector in the rectangular form that it's in. If I want to find out what that angle theta is, it's going to be equal to, remember that the tangent of theta, so there's theta, is going to equal opposite, which is VC over VR. And VC over VR is 20 over 10, because this is opposite and that's adjacent. Now we know that the tangent is going to equal 2, but we want to find out what theta is, so we take the inverse tangent. And I have a calculator online open. We're going to use that. Here I'm going to put, let's see, function. There we go. Inverse tan of 2. And we want to make sure that we're in degrees. We are in degrees, so we're good. Now we know that angle is equal to 63.4, 63.435. I think that's quite a lot of precision for a problem like this. I guess it depended on how close you needed to get to the actual answer.